Okay, turning point. What is a turning point? A turning point of a polynomial function, we can say, is a point where what? Where a polynomial function, I would say where a polynomial function changes from where? From increasing towards to decreasing, or from decreasing to where? To increasing. So just like the graph here, we can see here at this point, the graph here changes from decreasing to increasing. So this is one turning point. And here we can see also this is another turning point. Here we can see this another turning point. Some textbook, they call it local extrema and local minima. Now, the essence of this short video is to give you a formula for finding the number of what? Of turning points, possible turning point that a graph should have. Now, one theorem, let's talk about this. If you have let's look at this, a polynomial of degree n has at most n minus 1 number of what? Turning points. Now, what do I mean? If you have a polynomial of degree 5, the maximum number of turning points you can have is 4. So it means you could have less than 4, but the maximum should be what? Be 4. So just a typical example, if you have a polynomial of degree 2, I mean, the maximum number of turning points you can have is 1. So like in the case of parabolas, right? So, and that one turning point is called the vertex. So here I will just give us a formula quickly where we can use to find the number of turning point without graphing. So this is number of turning point it's equals to what? It's equals to number of what? Real zeros of a polynomial minus 1 plus number of even what? Zeros. Please take note of this formula. It's very important. We will use it shortly. Now, what does this mean? To find the number of turning points of a polynomial function is the same thing as the number of real zeros minus 1, then plus the number of what? Even zeros. So even zeros means what? The zeros that have even multiplicity. So let me just give you, let's solve these examples. So look at these functions. Here, the polynomial function are already factorized, so we can easily know the number of zeros, right? Okay. Now, if you look at this number 1, how many zeros do we have? So you can see we have 3 zeros. X equals to what? 0, x equals to 2, and x equals to what? Minus 3. So we have 3 real zeros. And based on our formula here, if we want to find a number of turning points, we just need to use the number of real zeros, so which is what? 3. So the number of real zeros here is, so let's say number of turning points it simply equals to 3, which is the number of real zeros, minus 1, then plus. Plus means what? We need to add what? Look at the last term here, which is the number of even zeros. When I say even zeros, I mean zeros that have even multiplicity. But if you look at this one here, you see, what are the multiplicity? The multiplicity means the number of times the zeros are repeated. Here, the multiplicity here is 1. The multiplicity here is 1. The multiplicity here is also 1. So you can see they all have odd multiplicity, right? So since you have odd multiplicity, it's like just you're adding 0 because you need the one with even multiplicity. So this will just give us 3 minus 1, which is 2. 2 plus 0, this is going to be 2. So it means that this polynomial function has two turning points. So it's going to have two turning points. Now we are not graphing it, so we just want the number of turning points. Now for this question, question number 2, also the same. The number of turning points is going to be, how many zeros do we have here? Look at the zeros. We have x equals to 0, x equals to 1, and x equals to what? Minus 2. So we have 3 zeros. So we put it 3, then minus 1, then plus the zeros with even multiplicity. If you look at this 0, here x equals to 0, what is the multiplicity here? Because the power here is even, so it means you have only one 0 that have even multiplicity. Here, this 0, the power here is 1, the power here is 1. So these are the multiplicity here, which you can call m, is 1. The multiplicity here, m, is also 1. But the multiplicity for x equals to 0 is what? Is 2. So it means that is the even 0. So you have only one of it. So we're not taking the number here. We're not, you consider 2 as the multiplicity, but why are we taking 1? We are taking 1 because out of the 3 zeros, only one of the zeros, which is x equals to 0, has an even multiplicity. So you take the number of zeros that have even multiplicity. So only one of it. So in this case, so you have 3 minus 1 plus 1, and this should give us what? This should give us 3. So it means if you draw this graph, you should have 3 turning points. Okay, now number 3. For number 3, we see that what are the zeros? We can see the zeros from here. X equals to what? 3. X equals to, now if you look from here, this is x squared plus 1. So you don't have a real 0 here because this will give you a complex 0. So you don't need to worry about it. Just go to this one. From here we can get x equals to minus 2. So it means the number of turning points it's simply going to be how many number of real zeros? Again, look at the formula. Number of what? Real zeros. You need the real zeros. So how many real zeros do we have? We have only 2 real zero, which is x equals to 3 and x equals to minus 2. So it's just going to be 2, then what? Minus 1, then plus. Now, how many of these real zeros have even multiplicity? And as you can see, only x equals to 3. Because the multiplicity of x equals to 3 is what? Is 4, right? So, which is even. So, only one of it. So, it means you have to add what? Plus 1. And this should give us what? This should give us 2. So, this graph, if you draw the graph of this polynomial function, you should have only two turning points. Then finally, this one here, number of turning points. Number of turning point here how many real zeros do we have? Look at the real zeros. But here we can rewrite this as what? X minus 1 and x plus what? Plus 1 all to power what? 4. Then x plus 3 all to power 3. So this becomes x minus 1 to power 4, x plus 1 to power 4, then x plus 3 to power 3. So what are the zeros? These are the zeros. The zeros are x equals to 1, x equals to minus 1, and x equals to what? Minus 3. All of them are real zeros. Now, what is the multiplicity? For x equals to 1, the multiplicity, which I can call m1, is what? Is the power here, which is 4. For x equals to 1, the multiplicity, I can call it, is also what? 4. But for this one, the multiplicity is 3. So here, first of all, the number of real zeros, how many real zero? You have 3. Then minus 1. Then plus the out of the real zeros, how many of them have even multiplicity? So here you can see we have two of them because x equals to 1 has an even multiplicity and x equals to minus 1 also has an even multiplicity. So it means we have plus what? Plus 2. And what is this? This is going to give us what? 4. So it means if you plot the graph of this function, this polynomial, we should have 4 number of what? Turning points. Okay, so I hope now this tutorial is clear on how to find the turning point from where using the formulas when you already have the polynomial in a factored form. All right, thank you for watching.